Hello everybody, my name is Derek Kominick. I'm the consulting manager here at Matricon, and today I'd like to talk to you about getting started with IIoT using OPC UA. This is one in a series of videos talking about various aspects of the industrial Internet of Things and Industry 4.0, and basically how people can start to practically start engaging with this technology and using it in their businesses. So to date, we have seen and heard a lot about what's possible when you start adopting cloud technologies and the great benefits that they're going to bring. But looking at the hype curve, slowly people are starting to shift from the excitement, the initial excitement that comes from what's possible, and starting to ask, okay, so what's next? How do I actually take these technologies that I'm hearing about and that are coming down the line, and how do I actually start adopting them into my plant or into my business? So that's what we'll talk about in this session. So if you were to look at some of the things that are emerging and the challenges and also what the infrastructure is that you're trying to work with, we can see that when we look at our various plants at different locations or even communications between different businesses, they really break down to the ability to communicate for the systems that are within them or the shop floor and also in the business environments, and also trying to take advantage of the clouds and the cloud-based computing, whether that's on premises in subnets or whether you're talking out in the internet. And then how do you establish all the connections between them and embrace that, I guess, within the business, which we call digital business transformation. So the emerging challenges that some of the ones that we see are, number one, well, how do you run a digital business model? How do you take advantage of all this extra information that you have, even the analytics that you throw at it? What do you actually get out of it? Second, it's the whole idea of how you integrate the cloud and the edge computing that's happening. So yes, you can generate a lot of information, but number one, do you need to throw all of that up into the cloud so it can then get processed and analyzed? And or can you, for example, simplify it, which is a lot of times what fog computing refers to. We're also looking at how you can start working with various other parties, whether it's within the company or even within your supply chain, or how you can extend the functionality or the data sharing that exists between different entities now that it becomes possible with this. And as well, as a final point, a key challenge is how can people start taking advantage of this? So even though the systems may have more access or more intelligence and better information about what's happening right now in the company, how can people actually use this in their day-to-day jobs? Whether it's the maintenance, people working on the various subsystems, making sure that they're up and running, whether it's the operators or people trying to make decisions on the business side of things. So trying to tie all that together with these various new technologies and new processes that have to roll in so that the overall culture can shift. There's also a question of how to work with existing infrastructure. People have invested a lot of money and time into putting systems in to establish the communications that they have today. So they have also a requirement to meet the rate of return on their investments currently. And therefore, how are they supposed to migrate to take advantage of the new technology without ripping and replacing what they've already put in? There's also challenges working with different vertical silos, because again, a lot of the open standards that exist today exist within a particular vertical. But as we start to blend and, like I said, go from the me to a we type ecosystem, or even between different departments, how do you bring those together? Open data connectivity is a key question. Again, how you bring it together, but also how do you make sure that this makes sense? So as you bring the information to the cloud, you have to make sure it has some kind of context, because just throwing numbers into the cloud does not mean you're going to get useful information out of it. You have to have some context behind it. So given that there are many different systems involved, how do you get all that put together? And then lastly, but also incredibly important, is data security. So sharing is possible and you've got the existing infrastructure and you can retrofit it to talk to the cloud, but how do you ensure that those systems remain safe? So those are some of the real world challenges that people face. Now, when we look at this, the topic can be broken down into 3 key areas with various points within them. So first of all, just data connectivity overall, right? The visibility, what can you see on the plant floor, the shop floor? How far down can you see it? Is it just the top level systems of the controllers? Can you see all the way down to the sensors? Can you see the diagnostics on the various equipment components, or is it just overall what's happening with the process? How much context do you have? So again, do you know what the units are coming off of these various systems so that you can perform proper unit translations, or also do the proper scaling on them and such? The security and also the reliability to ensure that you actually can continuously get all of this data. So you receive the data that you're connected to. So that's data connectivity. That's a key or a very important aspect. Now, the data has to travel over something and come from somewhere. So on the edge, if we break it down, looking at the bottom levels where basically the physical assets are meeting the digital world, somehow you're turning the data, or you're taking the information from the real world and the physical world, and you're putting it into getting it into the cyber world, right? So this is sort of the edge of where the overall IIoT exists. So things like achieving better local control, filtering some of the data so you're not sending so much of the data upwards, and also performing some of the local analytics. So basically at site or at the controller, rather than sending it into the cloud for decision making and then coming back down. Okay, so overall the term is fog computing as far as what you do with that information at the edge, but then you also have to get that information up into the cloud. So the third one is the cloud computing aspect, and that's basically a question of how do you collect this data, how do you do the analysis, and how do you collaborate? How do you bring in different subsystems? How do you allow people to work with them? But those are really the 3 key areas that need to get addressed in order to have a strategy, technically at least, for how you would implement the industrial Internet of Things type technologies. So one of the key places that we can start looking at this from an IT perspective is what the network looks like. So in order to share the information from the shop floor up to the cloud and allow everybody to access it, there's really only so many ways that you can move that data. Now, people talk about sending information directly from the shop floor into the cloud. But if you look at it right now, currently plants are set up on the Purdue model, where basically you've separated the various layers in the company. So whether you're talking to the plant network for the actual controls, or the operations network, or the business network, and of course firewalled off the different layers between them, and have very strict guidelines for how you're going to allow that exchange of information. Some companies have this, more rigid. Others are a bit more relaxed about how they move the data. But regardless of what your policies are, there's already infrastructure that you'll have in place to facilitate movement of that data. Now, traditionally, moving information between these networks has also been a bit tricky, just because often the capabilities of the software to keep the plant running depended on a fairly open environment, whereas IT has always tried to secure that environment and therefore restricted some of the ports that can be used, or even some of the technologies that can be employed in order to share data between different network layers. So that has typically been seen as a bit of a challenge and a bit of a struggle between the IT and the OT guys. But given the coming now of the IIoT, or the cloud technologies, really the idea is to bring in a new type of networking environment, where even though we continue to use the networks and the systems that we've built so far, the new technologies that are coming in for the actual data communications between them basically flatten it. So you're basically looking at, let's say, an enterprise network perception and the control network perception, and there is an easy, rich way to move the information between the control network and the enterprise without people having to necessarily be aware of all the different steps that are required and the complexities to actually move that data between them. Now, to a large part, as we make smarter components, so whether that goes the communications into the controllers, the sensors, how we manage alarms, or the applications that sit on the enterprise level, as we make their communications more secure by default within the actual components, the easier it becomes to allow them to share information across the networks, because they already protect the data. So part of the protection starts to move into the edges or down into the systems, rather than relying purely on the network and from an IT perspective to provide that security. Right? So the OT components are starting to also be intelligent and aware and integrate better with the overall IT system. So the idea is that as we bring these new technologies together, that it becomes the perception even of how difficult it is or not to move the data starts to shift towards making it look fairly easy. Now, this is not just a fantasy or basically a plan in the future. The major companies out there that are coming, let's say, from the IT world, are already engaged in this as well. So, for example, allowing the cloud to collect data from various OPC UA enabled devices is already something that's available. Right, so as an example, as I show in this picture, this is something I took at the Hanover Fair just this year. And I mean, we had a demo set up. We're working with Microsoft. Various vendors brought their OPC UA enabled devices, and they were being fed directly into the cloud. Now, in a plant network, of course, you're going to have firewalls and such, so there's going to be a few more hops set up. But the idea is that the data that comes off the device is encrypted right from the source, and then as it makes its way through the network, your data is protected. Right, so even the large companies that are coming in, like Microsoft, to come down and actually look into the shop floor, they are aware of using OPC UA, or the fact that OPC UA facilitates this secure data transfer, and they have actually accommodated this. So, for example, Azure is able to pull that data in directly. So if we look at networks overall today, they primarily follow the Purdue model, so basically a combination of the ISA 99 and 95 standards for how you set this, overall your plant networks up and where data resides and what the middleware looks like. But still, within most organizations, you will find that there are islands of data, and they don't necessarily share the information amongst each other easily. Okay, there's also a high infrastructure cost because there is a lot of middleware that's required, and a lot of it runs on complete full-blown PCs, so there's a lot of maintenance involved in actually ensuring that those PCs continue to run. So just between the maintenance and trying to set all these communications up, that generally creates a fairly expensive solution. Although compared to, say, 10 years ago, the visibility has already increased by quite a bit, but still it's quite expensive. So as we start to move towards the IoT, the idea is, well, take what you've already got, because it already works, and now start to improve it or start to build on that. Okay, and in this case, when we're trying to use OPC UA, this actually acts as a differentiator, because currently a lot of companies don't use it yet, and they haven't realized the benefits that you get when you start bringing in OPC UA enabled components, whether it's OPC UA directly inside the devices sitting at the lowest levels, or on the higher network layers, and just making it extremely easy to move the data between the systems, being firewall friendly and basically just easily implemented. Okay, so we still see some of the division between different locations or between the plants and the business side. So we still see that there is a bit of a gap. However, this is the right place to start is with what you have. Now, as we move into a view of what will happen in the tomorrow type world, we're still going to have, of course, the Purdue model, but now we're going to start shifting towards a more IIoT-centric model, where basically the perception, at least, of how data is moved is a bit flattened, so you can get information into the cloud relatively easily, and you can also get the results back down as needed. Okay, so this increases data visibility and also the context, again, assuming we're going to be using OPC UA to facilitate that. Now, how do you do this, right? That's the first question that typically I hear when I'm dealing with various companies who are looking how to engage this and take advantage of it. So it's a fairly standard process that you can follow. Number one, you do need to get your systems to start moving towards using OPC UA, because that creates or provides a common method across all of your operations and all your layers for moving that data without losing the context of the information or the structure of the data, and at the same time actually increasing the, let's say, the security of that information. So you start with the legacy infrastructures you can see at the bottom of the screen, where basically we've got the proprietary, let's say, devices or just legacy systems that have their own native protocols, and typically you would have an OPC server already probably talking down to them. Okay, so doing the translation from the native protocol to OPC. So one of the first things that you would do as you start to prepare to phase it, you don't rip those legacy systems out. What you can use is, for example, something like a Matricon OPC UA wrapper, which basically converts those OPC classic servers to act like or appear like a UA server for future UA clients to be able to talk to them. As well, you probably are starting to look at what will you do in the cloud, let's say. So for example, putting in a cloud historian, having an IIoT hub, so basically something that knows how to collect this information or to feed it into the cloud historian in this case. Okay, so that's the goal if you want to get it there, but how do you make that jump? Now, one other thing, you can also, of course, start adding in OPC UA devices today. So as new systems come out, as you get new PLCs or new controllers, they are going to start having OPC UA built directly into them. So both of these can actually be then fed into, for example, an IIoT gateway, which basically has the job of taking OPC UA traffic and putting it onto a transport that's typically used to move data from, let's say, your one location into the cloud, right? So these are transports like AMQP or MQTT. These are transports that are used to basically carry that data to the cloud. So one of the ways that you start getting all of this stuff connected together is, number one, you have to start putting in OPC UA components, which will then translate from your existing systems. Start adding, when you're choosing new components as well to put into your plants or into your environments, start using OPC UA enabled devices, because now that lets them natively talk to that while keeping the data secure, and then start building upwards from that. Okay. Now, there are two fairly exciting things that are coming out, or two capabilities that will be coming out in the OPC specification. So, as you know, OPC UA has been around for years now, and it continues to evolve. At least parts of the specification continue to evolve as per design to basically adapt to new capabilities that emerge as technology moves forward. On one such track, you could say, is the ability to move data on different transports. So we've seen OPC UA, for example, being transported over HTTPS, or just binary traffic traveling over TCP connections. Well, the way that you do communications up to the cloud in a secure way is basically by using transports like AMQP to basically use a broker that takes information or accepts information from a OPC UA server and stores it or buffers it so that a subscriber from the cloud can come in and pull that data from the broker. This is the advantage of separating the subscriber or the client and the OPC UA server sitting on your shop floor or in your organization, because they don't actually need to talk directly to each other. This means that you can easily scale, especially when talking to external systems, to allow many subscribers to talk to your broker, as shown in point 1 here. And at the same time, without disrupting, let's say, the server that's sitting down below and actually generating the information. Second, this new addition is also going to allow you to do broadcasts within your network. So when you're sitting in the local environment and you may have, for example, many clients or many applications that want to fetch information from a server, rather than all of them connecting to the server and requesting the information, they can just pick up on the information that server is publishing locally, and that's basically using a broadcast. Okay, so while typically the traditional way that OPC UA or OPC in general work was having a client and a server which make a connection with each other and exchange information based on what the client has requested. In this case, in part 14 of the OPC UA specification, you're now seeing an additional method which allows the server to be configured by the administrator to publish certain values, and then as many subscribers as needed can actually pick that information up and receive it. So once this is complete, what that does is it helps to further eliminate additional middleware that's needed to get information from your actual source into, for example, the cloud, or to feed it to various other clients on your local network. So what that would look like is you still have your legacy systems, which I show in the bottom left, which can still generate data or take part in this infrastructure by using the UA gateway, and still, the OPC UA wrapper, which feeds into the IIoT gateway, which then feeds information into the cloud. But you can also see the addition on the right-hand side, OPC UA devices that can also potentially talk directly into the cloud, or at least push information to the cloud by using the pub/sub specification, the publish subscribe specification I just mentioned from OPC UA. This allows the information that's generated right from the device to be directly sent to the cloud. It's still encrypted. It still requires authentication even on the subscriber side, so that it still maintains the confidentiality of the data that you have. So security is maintained, but it is much easier to get that data out without necessarily having to go through a lot of different hops in between throughout the network that you have established right now. Okay, so this is where we're aiming to in the future, and why it's so exciting, because it basically simplifies architectures dramatically while allowing a secure communication to occur between or from the shop floors or from within your company out into the cloud. Okay, so this is sort of where we're heading to. Now, as in conclusion, to sort of combine these two things, number one, the first steps, practical steps that you can take today are to start migrating towards using OPC UA. This means that you don't have to disrupt your systems as they exist today, because you can continue to use, for example, OPC, the classic OPC, and basically just adding in the components that allow it to talk as UA. And also to start just adding components or devices that actually have OPC UA built in already into them. This will allow you to reduce the cost that you currently have for middleware, because you typically would not then need many of the PCs that sit in between and translate between systems. Those systems can just talk directly across, for example, firewalls, because they employ secure communications and don't pose a threat to the infrastructure. So things like UA wrapper, UA proxy, or even the UA Modbus gateway will allow you to do this directly, right? To take the first two will allow the classic and UA components to work with each other. UA Modbus gateway would allow Modbus devices to basically feed data directly up in or expose it directly as OPC UA. And you can also use additional components like the industrial data logger to buffer some of this information, or to also provide connectivity to the legacy systems, and at the same time expose it as OPC UA. Now, if you are a vendor, one thing that's also worth looking at is how are you going to enable your products with OPC in general, as OPC UA. So for this, Matricon has actually an OPC UA SDK that provides the broadest range of functionality, basically being, or where you can use it, whether you put it down into a small device in an embedded environment, or whether you want to use the OPC UA SDK to develop UA capabilities for your applications, your PC-based applications. Both of those ranges are covered by a single UA SDK. So that's something definitely to look into. Second, it takes time to actually change your business model from, let's say, the traditional way of doing business to looking at what does digital business transformation mean to you. So this is a multi-step process. It doesn't happen overnight. And you can start looking at what will you do at the edge. So for example, as you gain more visibility down to these various devices, the question is, what can you actually do with that data at the source? So what type of analytics can be performed locally as you're sharing them between different systems in your own network, and also what calculations can be performed at that level before you feed them up into the cloud. Once you get the information into the cloud, then of course the question is, well, what will you do? What type of analytics will you run on that? And how will you disseminate that information to the workforce and between the different systems? Okay, so that actually often leads to doing a POC, or a proof of concept, where you now are starting to be enabled with the UA technologies, so you have that free movement of data possible throughout your systems. And now the question is, how do you, where do you see the opportunity for this to happen? Now, at Matricon, we deal a lot with various vendors who are vendors or end users actually, who are going through this process exactly, where they're also sort of scratching their head and saying, okay, we've got the whole concept of what IIoT does, and we've got some of the technology now that actually we can enable our systems to talk, but what can we do next? And typically a great way to get started is by doing a POC for that. And again here, this involves, again, industrial data logger if you're trying to bring the communications from various legacy systems together and then feed them up into the cloud. And at the same time, designing the cloud collector and the IoT hub, which basically work together to help you coordinate how you move that information up into the cloud. Okay, so hopefully you found this a useful overview of how you can start taking advantage of some of the IIoT capabilities by first starting the migration to UA, so your systems are actually more up to date for dealing with these new cloud type environments, and also some ideas of how you can start to prepare to actually transform your business into a digital business. I hope you guys enjoyed this presentation, and hope you take a look at some of the other videos we've made as well. Take care.